In this lecture, we are going to learn about the force system resultants. Sometimes when you apply a force on some object, this force will produce rotation or tendency for rotation. So this effect we call as movement, or in Sinhala we said it gurne, right? So Uh, in this lecture series, we will study how to determine the movement of a system of forces and calculate their resultant movement. Right? So we'll discuss the concept of movement of a force and show how to calculate it in 2 and 3 dimensions. And we'll provide a method for finding the movement of a force about a specified axis. Also, we'll see how uh, we'll define the movement of a couple. Then we'll show how to find the resultant effect of non-concurrent force systems. So those are the things that we are going to learn in this lecture series, right? So we'll look at what is the movement, then how can we calculate the movement in two-dimensional and three-dimensional systems, right? Then find we'll define the method to find the movement of a force about a specified axis, right? So then I will define what is the couple, movement of a couple. Then we'll see how we can find the resultant effect of non-concurrent force systems, right? So when a force is applied to a body, it will produce a tendency for the body to rotate about a point that is not on the line of action of the force, right? Sometimes body may rotate, sometimes body may not rotate, right? That's why it says it will produce rotation or tendency for rotation, right? Some force, when a force applied on a body, sometimes body may rotate about a point that is not on the line of action of the force, or sometimes may have a tendency for rotation, right? So it doesn't need to rotate always. It When some forces may only have tendency for rotation, right? So when you apply a force, it will produce a rotation or tendency for rotation about a point that is not on the line of action of the force. So this is called the moment. Sometimes sometimes this is called as a torque also, but in here in mechanics we usually call this effect as the movement of the force, or simply the movement, right? So for example, uh, and the movement of a force is a vector. So the movement is a vector, right? So whenever we say this is a vector, we know that it has two things, right? It has a magnitude and it has a direction, right? So movement of a force, or the movement or torque, is a vector. So it has a magnitude and it has a direction, right? So the movement of the magnitude of the movement of the force, we usually designate the movement by m, right? So the magnitude of the movement, the absolute value of the m, is proportional to the magnitude of the force F and the perpendicular distance to the line of action of the force from the point of the axis of rotation, right? Perpendicular distance, we'll discuss this in later, right? Just to remember, d is the perpendicular distance from the axis of rotation to the line of action of the force, not to the force, line of action of the force. Why we use the line of action of the force? Because we know that force is a vector. So any vector, if say this is a vector, so we can slide this vector without affecting its effects, right? So if this is the say if this is the uh, say if this is the axis of rotation, then we'll take the perpendicular. If this is the force, we'll take the perpendicular distance to the line of action of the force, right? So the movement, we can say m is proportional to the magnitude of the force and to the perpendicular distance, which we call also as the movement arm, right? So any movement is proportional to the magnitude of the force and to the perpendicular distance to the line of action of the force, right? So if we, for example, consider a wrench used to unscrew the bolt. You can see this in figure, right? If a force is applied to the handle of the wrench, it will tend to turn the bolt. It will tend to turn this bolt about point O. If this is point O, so it will tend to turn this bolt about point O, right? The magnitude of the, we know that magnitude of the movement is directly proportional to the magnitude of the force and the movement arm. So we can see in here, in the first picture, right? The the movement m is proportional to the f and d. D is the perpendicular distance, right? Here, what is the movement? So m, we have the same force, but now d is not the perpendicular distance, right? So here the perpendicular is distance is this one. So this is, if this is theta, then this one is d sine theta, ft sine theta, right? So which one is larger here? We apply the same force, but the movement in here is larger than this one. Why? Because even though the magnitude of the force is same, the perpendicular distance from the point O to the line of action of the force is different in these two cases, right? Here it is d, here it is d sine theta. We know theta is from 0 to 90, so sine theta is from 0 to 1, right? So this distance is smaller than this distance. Because of that, the movement in this case, movement is smaller than this, right? So I just want to show that movement is directly proportional to the magnitude of the force and the movement arm, right? So how about in this case, movement is proportional to force, which has the same force F. What is the perpendicular distance to the point O? It is 0, right? So the movement is equal to 0 in this case, because the line of action of the force is going through the axis of rotation. So in that case, the perpendicular distance to the line of action of the force from the point of rotation or the axis of rotation is 0. So the movement is 0, right? So what you should know from this slide is that when you apply a force on a body, this force may rotate the object or it may produce a tendency for rotation. So this effect will call as the movement or torque or the movement of the force. So the movement of the force we designated as m, which is proportional to the magnitude of the force and the movement arm. Movement arm means perpendicular distance. Perpendicular distance to the line of action of the force, right? So we'll discuss these things in the next slide. Just to remember, movement arm is the perpendicular distance to the line of action of the force from the axis of rotation, right? And the movement is a vector, so it has direction and the magnitude. So the magnitude is proportional to the magnitude of the force and the movement arm. We'll see how to find the direction in the next slide, right? But just here you should remember these things. What is movement? And movement is a vector, and the magnitude of the movement is proportional to what, right? Okay, now let's see how we can find the magnitude and the direction of the movement. Say that force F and point O are lies in the same plane. The movement of the force F about point O, I'll designate it as M naught. Okay, movement of the force F about point O. If we take movement of the force F about point A, we can designate it as MA. If we take the movement of force F about point B, we can designate it as MB, right? So since this is the movement of force F about point O, I designate it as M naught, right? So magnitude of the and the direction of the movement, right? So first we'll use the scalar formulation. We can determine the magnitude and the direction using scalar formulation and vector formulation. First we'll discuss how to determine these two using scalar formulation, right? So the magnitude we can determine, say magnitude of the movement about point O, m naught is equal to magnitude of the force F time t. T is the movement arm or perpendicular distance from the axis at point O to the line of action of the force, right? So this is the movement arm or perpendicular distance from axis at point O, right, Point O to the line of action of force, right? So then the direction, so this is how we determine the magnitude. The magnitude of the movement is equal to magnitude of the force times movement arm, right? So the direction of m naught is defined by its movement axis, which is perpendicular to the plane that contains the force F and its movement arm D, right? So movement axis, the direction of the movement axis is always perpendicular to the plane that contains the force F and the movement arm D. The right hand rule, we use the right hand rule to determine the sense of direction of M naught, which means that which direction it rotates about the point O. Sense of direction means the direction of rotation, right? So according to this rule, the natural curl of the fingers of the right hand as they are drawn towards the palm represent the rotation, or if no movement is possible, there is a tendency for rotation caused by the movement, right? So if you take your right hand, then keep it when direct your thumb in the direction of the movement axis, then curl, natural curl of your fingers rather will will show the represent the rotation direction, right? So this is how we determine the magnitude and the direction, right? So here this one is the three-dimensional view of this system, right? So movement vector is demonstrated by uh, by a curl around an arrow. See, this is arrow. Using this curled arrow, we usually demonstrate represent the movement vector in three dimensionally, right? So in two dimensions, so this is the two dimensions, so the movement vector is represented only by this curled arrow as shown in this figure, right? So this is how movement can be represented in three. This is the three-dimensional view. This is the two-dimensional view, right? In three-dimensional view, use a curl around the arrow to represent the movement vector, right? In two-dimensional, just a curl arrow to represent the movement vector, right? Okay, first let's see how to calculate resultant movement of forces in 2D space, right? So we know that if there is a one force, it will produce a rotation or tendency for rotation, right? So if there are more than one forces like this, so all these forces will produce rotation or tendency for rotation. So as we know in our previous discussion, if there are two forces, if we can find the resultant force, one force which represent all these two forces, right? If there are more than two forces, still we can find the resultant force, right? In the same way, if all these forces produce different rotations, then we can find the resultant moment of these forces, right? So the magnitude of the resultant force, we use the resultant force, we usually demonstrate it as mr. R represent the resultant movement, right? Movement we represented by m, resultant movement we represented by mr, right? So if we want to take about some point, say about point a, we use a. If you want to take about point b, we use mrb. If you want to take about point o, we use mro, right? So the magnitude of the resultant moment about point O, we can represent it as MRO, can be determined by finding the algebraic sum of the moment caused by all the forces in the system, right? So we are still under the scalar formulation method, right? So we use algebraic sum determined by finding the algebraic sum of the moment caused by all the forces, right? Since this is the two-dimensional space, this F1, F2 and F3 are on the same plane, or we can say they are on the XY plane, right? So now we want to find the movement, resultant movement of these three forces, right? Say about point O, right? So say, what is the movement of F1 about point O? We know if you put your use the right hand rule, the movement is in this direction and we can say it is M1. Say it is M1, right? So the force F2 is in this direction. So M2, if you put the right hand rule, the direction of the M2 is in this way, right? So the movement of the F3 force in this way, right? So uh, so we say, as a convention, counterclockwise movement are considered positive, right? So this is clockwise movement and this is counterclockwise movement, right? This is counterclockwise, right? So we, as a convention, we take this movement as positive, right? So if you want, you can say this one also as positive, right? But usually we take counterclockwise movement as positive, right? So then we can find, as in here, if we take the algebraic sum of these movements, then we'll get the movement, resultant movement, right? So the resultant movement mr naught, we can say f1 times d1, right? So this is the m1, right? Since it is a counterclockwise, is it a positive movement, right? So then m2 is in this direction or clockwise direction, so it is negative. The magnitude of the force F2 times d2, right? So then the F3, you can see it is a counterclockwise, so it is positive. This is M2, right? Then M3 is equal to F3, magnitude of the F3 times D3. D3 is the moment arm, right? So M1 minus magnitude of the M1, magnitude of the M2, magnitude of the M3, right? M1, magnitude of M1 minus magnitude of M2 plus magnitude of M3, you get the magnitude of the resultant movement, right? So this is the magnitude of the resultant movement, right? So if this value is plus, then which means that the resultant movement is in counterclockwise, because we say counterclockwise movement are positive, right? So if the value of these things is minus, then which means that resultant movement is in clockwise, which means, because according to our convention we took counterclockwise movements are plus, so if this is negative, which means that it is in clockwise, right? So if we take for example, right, say that m1, the magnitude of the m1, say magnitude of m1 is 5, magnitude of m2 is say 10, magnitude of m3 is say 3, then what is the resultant movement about point O? Say mr naught is equal to m1, magnitude m1 minus magnitude of m2 plus magnitude of m3, right? So this is m1 is 5, m2 is 10, it is minus 10 plus m3 is 3, right? So we will get minus 2, right? The resultant movement is minus 2, which means that the resultant movement mr is in this direction, right? In clockwise direction, not counterclockwise direction, right? If it is positive, which means it is in counterclockwise direction, right? So this is how we find the magnitude of the resultant movement of several forces, right? So based on the whether it is plus or sign, plus or negative, we can say that the rotation is in clockwise or counterclockwise. Okay, now let's see how we can find the determine the movement of these forces about point O, right? So if we take the first example, the example A, here we know that movement, say movement about point O is equal to the magnitude of the movement, right? Is equal to magnitude of the force time d, right? So what is the magnitude of the force here? 100, right? Times d, perpendicular distance is 2, so it is 200 Newton meter, right? So what is the direction, what is the rotation of this movement, which is in, if you take about this point, so this force, if you use the right hand rule, the axis of rotation is towards the board or towards this point, right? And the rotation, the sense of the rotation is in this direction, right? So this one we can say, we can denote like as 200 Newton meters in this direction, right? So if you take this one, take the B, we know, we can say M, the moment of this point was about point O is equal to, the magnitude is equal to magnitude of the force times D. The magnitude of the force, what is magnitude? 50, right? So what is the moment arm. Moment arm is the perpendicular distance from the axis of rotation to the line of action of force, right? What is the perpendicular distance? What- This force, the line of action of this force is this, right? So what is the perpendicular distance from the to the line of action of force from the point of rotation? This is the point of rotation, right? Is this the distance? No, right? This is the perpendicular distance, right? So which means 0.75, right? So if you multiply this, you will get 37.5 Newton meters, right? 37.5 Newton meters. This is the magnitude. So what is the direction? If you take about this point, it will rotate like this, right? So it is in counterclockwise direction. So we can say the 37.5 in this direction, right? So how about here? Again, the movement about point O, the magnitude is equal to magnitude of the force times D, right? So magnitude of the force is 400 lb. Then what is the perpendicular distance from point O to the line of action of this force? It is 4 plus 2? No. This is the, so this length is the perpendicular distance, right? So this is 2 feet. So we can say this is 2 feet. So this distance is 2 cos 30. So this total distance is 4 plus this is 4 and this distance is 2 cos 30, right? So 40 times 4 plus 2 cos 30, right? Right? 40 times 2 cos 30. So we will get answer as, you will get our answer as 4 plus 40 times 4 plus 2 cos 30, which means if you solve this one, you will get 229 lb feet, right? So this is the magnitude. What is the direction? It is, if you take this force about this point, it will create this type of rotation. So we can say it is in this direction, right? So here, how about this force about point O? Our equation is the magnitude of the movement about point O is equal to magnitude of the force times D, right? So magnitude of the force is 60 lb. Then what is the perpendicular distance from the point O to the line of action of force? This distance, right? So which is 1 sine 45 times 1 sine 45. So this gives you 42.4 lp. If I write here, which is equal to 42.4 lp ft, right? So So this is the magnitude. What is the direction sense of the rotation? If you take about this point, this force will create this type of rotation, right? The direction is in this way, right? So this is how we demonstrate the rotation direction or the sense of rotation, right? So here again m naught is equal to Fd. Here force is 7 kilonewton and the perpendicular distance to this force, the line of action of force, this is the line of action of force. So this is the perpendicular distance, which is 3 meters, right? 4 minus 1, 3 meters, 7, 3 is 21 kilo Newton meter, right? So which direction the sense of rotation? About this point, this force will create this type of rotation, right? So it is in this direction, right? So this is how we calculate the moment and find the magnitude of the moment and the rotation, the sense of rotation, right? So we use the curve to show the sense of rotation, right? So whenever you are asked to find the moment of force about any point, you should provide the magnitude and the direction of rotation, right? Okay, in this question, there are several forces on the same system, right? Now, not only one force, you can see there are four forces, right? So all these four forces will tend to rotate this uh, rod. Okay, so then we want to find the resultant moment, right? We know that if we find uh, the each of these movements of these forces, we can get the algebraic sum of this, right? So we have an equation that tells the resultant moment about point O, which is equal to sigma Fd, right? When you use this equation, you should express or you should show which direction of the rotation is positive. So I take counterclockwise direction as positive, right? So sigma f, actually this is the magnitude of the f times d, right? So then I can write as if I take this force 50, 51, you can see about this force it will create this type of rotation. So it is clockwise rotation, right? So it is negative 50 times what is the perpendicular distance to the line of action of rotation is 2, right? Then if you take this one 60, you can see it going the line of action of the force going through the point O. So the line of the perpendicular distance is 0, right? Then if you take this force 20, it will create counterclockwise rotation, right? So I say plus 20 times what is the perpendicular distance from here to the line of force, which is equal to 20 times this length is 3, so this one is 3 sine 30, right? 3 sine 30, right? So this length from here to here is 3, so this one which is equal to here to here, right? So it is 3 sine 30, and if you take this force, it will create clockwise rotation. So minus 40 times what is the perpendicular distance to this, the line of action of force is from here to here, right? 4, this length up to here is 4, and this one is 3 cos 34 plus 3 cos 30, right? So if you solve this one, you will get it as minus 334 Newton meters, right? So what does this minus sign means? We took that our rotations if in this direction as positive. So this minus means our mr naught is 334 Newton meters in this direction or in clockwise direction, because we took counterclockwise direction as positive, so we got the minus sign. So which means that the resultant moment of these forces about point O is in clockwise direction. So now we are going to use the vector formulation method to find the movement of a force about a point, right? So we have discussed about the scalar formulation method, and now we are going to discuss about the vector formulation method to find the movement of a force about point O, right? Say the F and O are on the same plane. So the moment of force F about point O, or actually about the movement axis passing through O and perpendicular to the plane containing the point O and force F, can be expressed using the vector cross product like this. Okay, the movement of O, we say that we learn that movement is a vector, so we use the bold letters to represent vectors. M naught, which means that movement of force F about point O is equal to R cross F. R is represent a position vector. R represent, so R is the, so R represent the position vector. Okay, position vector. R represent the position vector directed from O to any point on the line of action of force F. Position vector directed from O to the line of action of force F. Any point on the line of action of force F. It shouldn't be, or it can be perpendicular, but doesn't need to be, right? So any point, it, the R can be here, or R can be here, R can be here, doesn't matter. It should be directed from point O to the line of action of force F, right? So F is the force, right? So so we can determine the movement about point O as R cross F. So this is not equal to F cross R, right? Should be R. Position vector comes first, then cross F, right? R cross F, right? So we know that uh, so you need to go back to your mathematics class and refine your the cross product knowledge. If you have forgotten, I have put some of the important cross product notes here, right? So I'm not going to teach these things. This is the magnitude of the cross product, right? If C is A cross B, then magnitude is equal to magnitude of A B sine theta, right? So like this, so you have to go through these slides, or either you should go back to your maths class. I think you learn all these things, right? Cross products, how to take the magnitude of the cross product, right? How to find the direction, right? So go back to your those maths class note and refine your knowledge, right? So in our case, what is important is we can take the movement about point O M naught as R cross F. R is any position vector directed from O to the line of action of the force, right? So magnitude we can take we know that magnitude of the cross product is equal to magnitude of the R, magnitude of the F times sine theta, right? So this is the magnitude of uh, the M naught, right? So we know from that we told that in the scalar method it is magnitude of the F times d moment arm, right? So this, if you take this r sine theta means it is the movement r actually, right? But in cross product you don't need to take those things, you just can take the r cross f, right? So the direction and the sense of m naught are determined by the right hand rule as it applies to the cross product, right? Therefore sliding r, and this one more thing there, the theta, this theta r sine theta, right? So this theta is measured, is the angle between the tails, right? So this theta is the, you know that in the cross product it is the angle between the tails, right? So what is the angle between the tails? Here you should slide this vector r to this point, right? So then this is the theta, right? We know that vectors can slide along the line of action of the vector. So you can slide this vector to here like this, right? So then the angle between the tails we use to calculate the magnitude, which is the theta, right? So the direction and sense of m naught are determined by the right hand rule as it applies to the cross product, right? Therefore sliding r to the dash position here, if you slide this position vector to this dash position and curling the right hand fingers from r, as in the picture you can see from r to the f, if you curl the right hand fingers, put the right hand here and curl your fingers, these four fingers from R to the F, then the thumb is directed upward or perpendicular to the plane, right? Containing R and F, and this is the same direction as the M naught, right? It is the direction of the movement axis, right? So thumb gives you the direction of the movement axis, and these four fingers gives you the sense of the rotation, right? You can see that this force create this type of rotation. So if you put your right hand here and curl you these four fingers, you can see the rotation in this direction, right? So this is how we can find the rotation, the direction of sense in the vector formulation, right? The axis direction gives by your thumb, right? So in vector formulation, so this is the expression that we use to calculate the movement r cross f. You should remember that should be in this order, right? R cross f. This is not equal to f cross r, right? This is wrong. It's not equal, right? Should be r cross f, right? So the magnitude then you can calculate by taking the magnitude of r times f and taking the sine theta. So theta is the angle between the tails, right?